The universe hums with secrets we try to decode with equations. But what if those equations are just maps of a territory we don't fully understand? What if the real shape of reality can't be drawn in numbers? Our best physics equations describe reality with stunning precision, but they fall silent on 95% of the universe's true nature. Dark matter clumps like ghostly scaffolding. Dark energy accelerates the cosmos expansion. The matter-antimatter imbalance defies symmetry. None of these were predicted by math alone. In 1514, Nicolaus Copernicus dared to propose a sun-centered cosmos. His model used perfect circles. The planets did not obey. Kepler later replaced those circles with ellipses. But even that perfect, mathematical system began to crack under the weight of precise observations. The universe does not bend to our equations. It demands we bend our math to fit its secrets. For centuries, astronomers added epicycles upon epicycles to match the stars' motions. Their math grew more complex. The truth remained hidden in plain sight. Here's the lesson: mathematics is our most powerful tool, but it is a hammer. The universe is not a nail. In 1609, Kepler published his 3 laws of planetary motion. They were born not from pure math, but from Tycho Brahe's messy, imperfect observational data. The 16th century holds a warning for modern physics, a lesson so profound it still shakes our understanding today. Our equations are maps, the universe is the territory, and some terrains defy every map we draw. Even Einstein's gravity, his elegant mathematical dance of spacetime, stumbles at quantum scales. The dance breaks, the music stops. We build mathematical castles to explain dark matter. They crumble. We construct equations to tame dark energy. They evaporate. The matter-antimatter asymmetry is worse. Our best math predicts equal creation. The universe chose sides. Every time we think we've tamed reality with formulas, the cosmos whispers back, "Try again." In 1915, Einstein wrote down his field equations. They described gravity as geometry, but they could not explain the expanding universe that took Hubble's observations to reveal. Mathematics gives us language, but the universe speaks in anomalies, in outliers, in data that refuse to fit. The 16th century astronomers faced the same dilemma. Their math was perfect. Their model was wrong. The Earth was not the center. The math had to change. And here's the shock. That same struggle plays out today. Our most beautiful equations may be as geocentric as Ptolemy's circles. The answer lies not in better math alone. It lies in the next observation that shatters our current framework. If this kind of wonder keeps you up at night, you're in the right place. Subscribe so you don't miss what comes next. In 1596, Johannes Kepler published a theory so elegant it seemed divine. He nested the 5 Platonic solids inside one another like cosmic Russian dolls, each orbiting a perfect sphere around the sun. The math was flawless, the model wrong. Tycho Brahe's precise measurements of Mars's orbit revealed a wrinkle no geometry could smooth. Kepler spent 8 years chasing this anomaly, his faith in perfection cracking with every observation. And there it was. Mars didn't trace a circle, it carved an ellipse. The universe had spoken, Kepler just hadn't been listening. His 3 laws of planetary motion emerged not from equations, but from data that refused to fit. This is the hidden rule of discovery. Beauty is a poor substitute for truth. String theory and the multiverse shimmer with mathematical perfection. But without a single experiment to anchor them, they float like ghosts in empty space. We build castles of logic, yet the foundation remains sand. Why do we keep reaching for equations as if they're the key? What if the key is shaped like Mars's orbit, an awkward ellipse we're too proud to see? Kepler tore down his Platonic dream because the data demanded it. Today, we shield our theories with predictive power and mathematical consistency. But consistency in a vacuum is just cleverness dressed as wisdom. The universe doesn't care about our symmetries. It obeys its own rules. And here's the cruel twist. We may not even know what questions to ask yet. The tools to measure dark matter or quantum gravity don't exist in our labs. They might not exist in our imaginations. We're solving problems with rulers when we need telescopes. Or perhaps microscopes for the fabric of spacetime itself. The 16th century taught us to kill our darlings when the data says no. Why do we hesitate to do the same now? Is it fear, pride, or the quiet terror that our math is just another geocentric model? Kepler's breakthrough came when he let go of the need for beauty. What if the next one requires letting go of math altogether? The universe isn't a proof. It's a mystery with no textbook answer. And here's the deepest whisper. The tools to crack this mystery might not even resemble science as we know it. They might arrive from art, from philosophy, from a child's question we've dismissed. The answer isn't hiding in equations. It's hiding in the next observation we're not ready to make. Tycho Brahe's Mars was the anomaly that rewrote astronomy. What is our Mars, the data point we keep ignoring? The next revolution won't come from better math. It'll come from a failure we can't yet explain. And when it does, we'll look back and wonder why we ever thought the universe was simple. Because it is, it's a story still being written. And we're just learning how to read the first page. Mathematics is a flashlight in the dark. It reveals shapes in the void, but cannot map the walls themselves. The physical universe is not numbers. It is textures, forces, and silent collisions of matter we cannot yet name. But the true shape of the cosmos lies beyond even the brightest beam. For centuries, we mistook equations for reality. Kepler's ellipses, Newton's gravity, Einstein's warped space, all were born from a simple truth: reality defies derivation. They were not proven in isolation. They were shattered, remade, and finally validated by observation that cut through mathematical dogma like a scalpel through bone. Here's the lesson. Every revolution began with a question no formula could answer. The orbit of Mercury, the bending of starlight, the redshift of galaxies, each forced us to abandon our equations and look again. Math is a tool, not a dictator. The next great truth will not emerge from a chalkboard. It will arrive in the noise of a detector, the flicker of a distant star, the asymmetry of a subatomic collision. These are the fingerprints of a universe that refuses to be tamed by symbols. We build our models on phenomena, on what we measure, then translate into equations. But translation is betrayal. Every symbol loses something. Every approximation hides a gap, and in that gap, the real universe breathes. The standard model is a mosaic of 18 free parameters. Why these numbers? No equation tells us. Dark matter, dark energy, the matter-antimatter asymmetry. These are not failures of math. They are failures of imagination. The answer will not be a more elegant equation. It will be a new way of seeing. A pattern in the data that refuses to fit. A signal that whispers, this is not what the math predicts. And when we listen, we will begin to unlearn what we thought was certain. The universe is not written in the language of mathematics. It is written in the language of what we measure. Then we translate it. Imperfectly, tentatively, forever. And every time we think we are close, the universe shows us another corner we never saw coming. So the next revolution is already here. It is hiding in the static of our instruments. In the questions we dismiss as noise, the answer is not a better formula. It is a willingness to let go of the flashlight and feel the walls with our hands. If math isn't the answer, what is? And how do we find it? If this journey stirred something in you, leave a like. It helps whispers of the universe reach more curious minds. And hit that notification bell so the next wonder finds you first.